We have two sorted linked lists. We need to merge them into one sorted linked list. The result should use the existing nodes, not create new values. At each step, we are looking at the current node of both lists. We pick the smaller one, we attach it to our result, then we advance that pointer forward. If list 1's value is less than or equal to list 2's value, we pick list 1. Otherwise, we pick list 2. After picking, we move that list's pointer to the next node. A natural first attempt is to manually pick the smaller head before the loop, then run the loop for the rest. But this creates a problem. Let's trace it. List 1 is 1, 3. List 2 is 2, 4. We pick 1 as the head. We store it as dummy. Then we move the current pointer forward. Now it's at 3. We enter the loop. 2 is smaller than 3, so we attach 2. But our chain is now 1, 3, 2. That's wrong. The problem is that dummy and our current pointer were both pointing at 1. Moving the current pointer forward skipped past 1 without building anything off it yet. We need two separate pointers, one to remember the head, one to track where we are currently attaching nodes. Let's retrace. Dummy is 1. Current is also 1. List 1 moves to 3. We enter the loop. 2 is smaller. Current dot next becomes 2. List 2 moves to 4. Current moves to 2. 3 is smaller. Current dot next becomes 3. List 1 moves to null. Current moves to 3. The loop exits. Current dot next becomes 4. We return dummy. The chain is 1, 2, 3, 4. Correct. But there is still a cleaner approach. What if we did not pick the head manually at all? What if we started with a fake node, a dummy node we create ourselves? The dummy node is just a placeholder. It has no real value. We attach everything after it. At the end, we return dummy.next. Now the loop handles every node, including the first one. No special case needed before the loop. The dummy node also handles edge cases naturally. If list 1 is empty, the loop never runs. The remaining list gets attached directly. Same if list 2 is empty. Here is the final solution. We create a dummy node. We set current to dummy. We loop while both lists have nodes. We compare. We attach the smaller one. We advance that list's pointer. We advance current. After the loop, we attach whatever list is remaining. We return dummy.next. The dummy node trick applies whenever you are building a linked list and do not know the head up front. It gives you a stable anchor. Your loop stays clean. No special case logic for the first node.